the first section is section 10.1 in the package, or this is your 8.2 in the textbook. So this section is about the language of hypothesis testing. So in this section we will determine the null and alternative hypothesis, the type 1 and type 2 errors, and also we'll learn how to state the conclusion to the hypothesis test. So the first thing is, what is the hypothesis? So the hypothesis is a statement or a claim regarding a characteristic of one or more populations. So this is the definition for the hypothesis. Now we test this type of the statement using the sample data, because you cannot have all the information about the entire population. So we only have the access to the sample, a portion of that, and we take that sample data and we make the conclusion or a claim or the hypothesis about that population. Now, hypothesis testing. So hypothesis testing, this is just a procedure that's based on the sample, right, evidence and the probability that's used to claim regarding a characteristic of one or more population. So the testing about the hypothesis is just the procedure that we base on the sample data, and we make some claim using the evidence and the probabilities. Now the steps in hypothesis testing. The first thing is you have to make a statement regarding the nature of that population. Once you have the claim, you collect the evidence to test that statement, and then we analyze the data and to see if that statement is true or not. There are two types of hypotheses that we are learning in this section. The first one we call that is alternative hypothesis. Alternative hypothesis. So usually we call this to be H1, and the second one is the null hypothesis. And we see what are the differences between these two. And for the null, we usually call that to be H0. So alternative hypothesis H1, this is a statement that we are trying to find the evidence to support. So we make some claim about something. That means we call that statement is the hypothesis, alternative hypothesis, because we are trying to prove, to solve that, to support that this hypothesis makes more sense comparing to others. Now this is the statement that makes some changes different from the original circumstances. In contrast to this, the null hypothesis or H0, this is a statement of no change or no effects or no difference, and is assumed to be true until evidence indicates that this is not true. So for a given population, we always have some types of null hypothesis. That means we already have some facts, some data that something is true, and we call that is the null hypothesis. However, if you look at that and you don't think that this claim or this fact does not make sense to you, then you suggest another claim or the alternative hypothesis, and your job is to use this hypothesis, alternative hypothesis, and use another evidence to prove that the existing data or existing fact is not true, and that is called a null hypothesis. Now there are three ways to set up the null and the alternative hypothesis. There are three ways. The first one we call that is the two-tail test. Two tails. That means the null hypothesis, we have some parameter that's already equal to some value, and now we make some claim. We say that the existing value, some value that was given, we suggest that is equal to some other value. That means that now the alternative hypothesis say that the claim is that they are not equal to the given data. So we have two-tailed test. So one, the existing one is equal. Now we claim that it is not equal. So this is two tails. Or you can have something called the left tail test. And the left tail test suggests that we have some null hypothesis. That means a parameter equals to some value. Now you suggest the alternative hypothesis that that parameter is less than that value, the given value. So you claim that now your data, your claim is less than the given value. So less than, so you call that to be the left tail test. And this is the trick. Look at the way of the error. If it's pointing to the left, you are using the left tail test. And if you claim that it is greater than the given value, then you call that to be the right tail test. And the right doesn't mean the error pointing to the right. So basically, we never accept the null hypothesis, because without having access to the entire population, we never know the exact value of the parameter, even though it is given the fact that it's equal to some value, but we never accept that the null hypothesis. But however, we can say that we do not reject the null hypothesis, even though we never accept that, but at the same time we do not reject them. Okay, this is just like the court system. We never declare a defendant innocent, right? You never say that that person is innocent, but we may say that he or she is not guilty. So we not innocent is the same thing as not guilty. Not innocent doesn't mean that this guy is guilty, but we say that it is not guilty. So that's kind of tricky, this one. So we do not we never accept that, but at the same time we do not reject it. Okay, so you never say that this is, we accept that, but we never say that we reject them either. Now let's go to the third example. So forming hypothesis. Now for each of the following claims, determine the null hypothesis. Then state whether the test is two tails, left tail or right tail, and determine the alternative hypothesis. We are given that in 2008, 62% of American adults regularly volunteer their time for charity work. Researchers believe that this percentage is different today. So now we are given the percent, this one. So this one is the existing data, the fact. So the hypothesis, the null hypothesis, is the one that is given, or the P, the probability is 62% or 0.62, right? This is given. Now, and then our researchers claim that this percentage is different from today. So this is the keyword. Different, that means is it not equal to the given value, or you can have it here. This is different, right? So that should be the two-tailed test. So different meaning that the percentage is different, or this is the two-tailed test, or the two-tailed hypothesis. And the alternative hypothesis denoted by H1 is the P is not equal to 0.62. Next one. According to a study published in March 2006, the mean length of a phone call on a cellular phone was 3.22. And then a researcher believed that the mean length of the call has increased since then. So the keyword is the given data, the existing one, or the null hypothesis, is that the mean is the mu, right? The mean is 3.25. That is the null hypothesis. That's a given that is existing. Now, someone suggests that claim that data now has increased. That means we're using the increasing, right, or pointing to the right, or this should be the right tail hypothesis. So now it is increased. Therefore, the alternative hypothesis should be bigger than the given one, the existing value. The next one, using an old manufacturing process, the standard deviation of the amount of Y put in the bottle was 0.23 ounces. So this one is the given data. Okay, so the null hypothesis, again, it's just the existing data, or the standard deviation is just 0.23. Now, with the new equipment, the manager believes that this one has decreased or less than, right? So the keyword here is the decrease or the left and tail test, and the alternative hypothesis is this given value now should be less than the given existing data. So there's two types of errors you may make while you are doing the hypothesis testing. The first type of error, we call that to be type 1 error. Okay, so the type 1 error is that we reject the null hypothesis when it is true. So the null hypothesis is the one that is given from the problem, from the population, from the data, and we reject that when it is actually true. Now, another type of error is called type 2 error. So type 2 error is that we do not reject the null hypothesis when the alternative hypothesis is true. So there's another claim, which is the alternative hypothesis is true, but then we didn't reject the null hypothesis. So this is the type 2 error. So let's see the 4 possible outcomes from hypothesis testing. Reject the null hypothesis when the alternative hypothesis is true. This is correct. Do not reject the null hypothesis when the null hypothesis is true. This is also correct. This is the hypothesis testing. Reject the null hypothesis when the null hypothesis is true. This decision would be incorrect because you reject them while they are true. And this is a type 1 error. That means we will make some error. Type 1 error. And then we do not reject when the null hypothesis, when the alternative hypothesis is true. This is incorrect. And this is type 2 error. So let's see with the example of type 1 and type 2. Now again, we use the same example as above. So again, in 2008, 62% of Americans, they do the volunteer work. Now, a researcher believes that this is different from today. A type 1 error is made if the researcher concludes that the percentage is not 62. Right? The type 1, that means we want this to be not equal to the null hypothesis. But when the true is still 62%, that means the null hypothesis is true, but then we reject it. That means we say that this is not the null hypothesis. And the type 2 error is made if the sample evidence leads the researcher to believe that the current percentage is still 62%, and when in fact this percentage is not 62%. That means we do not reject the null hypothesis. That means it is not actually equal to 62, but we do not reject that. Okay, when the alternative hypothesis is true. Try this one. Now again, we have the cell phone length of talking was 3.35, and they believe that it has increased. Now type 1 error occur if the sample evidence leads the researcher to conclude that the number is still bigger than 3.25, but in fact the actual mean length of the cellular phone is still. That means we reject the null hypothesis when it is still true. Okay. And type 2 of error, that means the researcher fails to reject the null hypothesis that the mean length of the phone call on a cell phone is 3.25 minutes, when in fact it is greater than 3.25. Alright, let's go to the next one. Now there's some more language about the hypothesis testing. The first one we call that to be the notation alpha. So alpha is called the level of significance, or the probability of making a type 1 error, and this is chosen by the researchers before the sample data is collected, and it's represented by the probability of the type 1 error, or the probability of rejecting the null hypothesis when we should it. Okay. Now beta is the probability of making a type 2 error. So alpha is type 1, beta is type 2. Or we are not rejecting the null hypothesis when we should reject them. Okay. As the probability of type 1 error increases, the other probability of type 2 error should decrease. So they are opposites of each other. One go up, the other must go down. Okay, let's try to finish the last one, or we state the conclusion to the hypothesis test. according to a study, again the same example, the mean length of a phone call on a cellular phone was 3.25 minutes. Now, that researcher again believe that the mean length of the call has increased. So suppose that the sample evidence indicates the null hypothesis should be rejected. States the wording of the conclusion. So if the evidence indicate that we should reject the null hypothesis, that means we have enough data, or there is sufficient data or evidence to conclude that the mean length of a phone call on a cell phone is bigger than 3.25, because we suggest that it's increasing, so it's greater than, right, because there's sufficient data or evidence to support that the data should be greater than 3.25. Now, suppose that the sample evidence indicates that the null hypothesis should not be rejected. So if it should not, then there is insufficient evidence to conclude that the mean length of a phone call on a cell phone is again greater than 3.25. Something wrong with my pen. Greater than, right. Okay. Now there's one extra example stating the conclusion. The mean score on the SAT math reasoning exam is 516. A test preparation committee states that the mean score of students who take its course is now higher than 516. So determine the null and alternative hypothesis. So again, from the data, from the fact, we have the original existing data is 5.16, or the null hypothesis. So the null hypothesis is the mean to be 516, but then the community they claim now is higher, or the alternative hypothesis, the mean should be bigger than, because it's higher, right? Now, if the sample data indicates that the null hypothesis should not be rejected, it states the conclusion of the hypothesis test. It states the conclusion. So the conclusion is that there is insufficient evidence that the mean score on the SAT math reasoning test of a student who take the test preparation course is bigger than or greater than 516, because we should not reject. So therefore, we don't have enough evidence, or we are insufficient. So there is insufficient evidence that the mean score on the SAT math reasoning test of students who take the test test preparation course is greater than 516. So this is the end of section 10.1 in the package, or 8.2 in your textbook.